Okay, guys, hopefully last night's homework went well for using sum and difference for sine and cosine. Today we're going to talk about tangent. Tangent is an entirely different world than sine and cosine. It is so much more difficult because if you just look at the formulas, you should notice right off the bat that you have fractions. And fractions is never fun, and you will see why in a minute. I'm only going to do one example. I'll do it a couple different ways just so you can see it, but you'll see in a minute why you don't want to just choose any two angles that you can. So I've given you four examples right here of two numbers that either add up or subtract to equal 255 from the unit circle. And technically you can use any of these, but I'll tell you right now, two of the four here you definitely don't want to use. And I'll just tell you why first, and then I'll show you why later on. So if you look at the examples I gave you, in the first one I gave you 315 and 60. 315 is a 45-degree reference angle. So when you look at your formulas for tangent, you're just going to have to find the tangent of alpha and beta. So alpha again is the first one, beta is the second one. So I'm going to have to find the tangent of that and the tangent of that. The tangent of 45 is real easy. Look right here. Tangent of 45, all 45s is 1. The tangent of a 60 is the square root of 3. Those are going to be easy to work with. But if you use any of the 30-degree angle ones, look what tangent is of 30 degrees. It's square root of 3 over 3. So that's a fraction, obviously. You're not going to want to put a fraction in a formula that's a fraction, because you're going to have to clean that up, and that's going to take you more work. So what I'm going to do is I'm going to avoid any 30-degree reference angles, which means I'm not going to use this one because 210 is a 30-degree reference angle, and I'm not going to use this one, obviously, because 30 is a 30-degree reference angle. I can use that one or that one because that's a 45 and a 60, and that's a 60 and a 45. Both of those are going to work out nicely. So I'm going to do this one first. So there's my alpha and there's my beta. It's subtraction. So I'm going to use formula number 6 over here. So that's going to equal, I'm just going to do it down here. It's very bright in here, so let me close this shade. Okay. All right, so we're looking at 315 for alpha and 60 for beta. So formula number 6, according to that, here's what it's going to be. It's going to be the tangent of alpha, 315, minus the tangent of beta, which is 60, over 1 plus their product. That means you're going to be multiplying those same two values together. So tangent of 315 times the tangent of 60. So unlike sine and cosine, where you had to find sine and cosine of two different angles, so 4 different things, you're only finding 2 things here. You're finding the tangent of 315 and the tangent of 60. Okay, here's what we got. Tangent of 315. That's a 45-degree reference angle. Tangent of all the 45s is 1, and that's in quadrant 4. Tangent's negative, that's going to be negative 1. Minus the tangent of 60, square root of 3. Good? Over here, it's going to be 1 plus that product. So you got to take those same two values that you found up here and multiply them together. So that was negative 1 times a positive square root of 3. Okay, so that'll give me negative 1 minus the square root of 3 over positive 1. Now, this is going to be plus. These are going to be a negative. So plus a negative is going to be minus. Okay. At this step right here, nothing cancels. Please don't think you can cross anything out. You never can. So if you attempt to cross things out, you're going to get things wrong. You can't cross these out because they're part of an addition or subtraction problem. And this will always kind of be what it'll look like. One of them will be identical, even with the sign, and the other one will have the opposite sign. So nothing's going to cancel. Now, here's going to be the hard part of this. When you get to this part, we've got to get rid of the radical in the denominator. There's only one way to do that. We're going to multiply the top and bottom by the conjugate of the denominator. And that's what you'll do for every single tangent one. So we're going to multiply by the conjugate, which will be 1 plus the square root of 3. And what you do at the bottom, you have to do the same thing up top. 1 plus the square root of 3. So we are multiplying by conjugate. Again, you have to do that every single time when you're doing tangent. So, there's no way to avoid that. So if you don't multiply by the conjugate, you know you did it wrong. All right, let's jump down and actually do that. So I'm jumping down here. All right, the top here. It's a binomial times a binomial. You're going to have to FOIL that. So I'm going to get 4 things up top. -1 times 1 is -1. -1 times square root of 3 is negative square root of 3. Now, negative square root of 3 times 1 is another negative square root of 3. And then negative square root of 3 times positive square root of 3 is a -3. This is how the top will always come out to be. You'll get 2 integers that you can combine, and you'll get 2 radicals that you can combine. So this will become -1 minus 3 is -4. The negative square root of 3 plus or minus another square root of 3 is -2 the square root of 3. That again is what it will always look like. Nothing will ever cancel. You'll get 4 terms that will turn into 2 terms. If that doesn't happen for you, then you did something wrong. Now the bottom I could FOIL, but since they're conjugates, the O and I in FOIL is going to cancel. Here's the O, these two. That's going to be a positive square root of 3. Here's the I, these two. That'll be a negative square root of 3. So they're going to completely cancel anyway. That's how the radical disappears. So I'm not going to bother FOILing. I only need to do the F and the L. So here's the F. First times first. 1 times 1, 1. Here's the L. Negative square root of 3 times a positive square root of 3 would be -3. Combine them, that gives you -2. All right. Again, that's how it'll always come out to be for tangent. You will get just a number on the bottom. It's not necessarily always going to be 2 or -2, but you'll get just a single number, no radical. All right, we just need to clean this up. So we're going to separate and simplify. So you got to take the -2 and put it under each term individually. So that'll be -4 over -2. And then -2 the square root of 3 over -2. Simplify both of those, and that'll give you your final answer. Negative divided by negative in both cases is positive. So this is going to come out to be 2. That's this. That's going to be plus. These cancel. Square root of 3. And that's your final answer. That, again, is the answer of every single tangent problem you're going to do. The difference is sometimes they'll be negative, sometimes this will be negative. They could both be negative. Only one of them can be negative, but that's the answer no matter what. Okay, that is the easiest way to do this problem. The hardest ways are going to be when you use any of these 30-degree reference angles. So if you use 30, 150, 210, or 330 to do tangent, it's going to make it a more difficult problem. So I just want to show you guys that one. So I'm going to do it with, I'll do it with 210 and 245. So tangent, we're going to go 210 plus 45. So here's my alpha, here's my beta, and now I'm going to plug everything in just like we did before. So this is now going to be formula number 5. Because formula 5 is when you have addition, and this is certainly addition. All right, here we go. So I'm going to take the tangent of alpha, which is the tangent of 210. I'm going to add that to the tangent of beta. And that is going to go over 1 minus, it's minus now, right there in the formula, minus, and then these two things multiply together. Tangent 210 times tangent 45. Okay. That's a 30-degree reference angle. If you need to look